I hope you're doing well. I guess it might not be morning if you're watching this, but I'm filming it in the morning, so good morning nonetheless. Today I'm going to talk about two other angle relationships that you'll find within a transversal and a coordinate plane. The first one is corresponding angles. So corresponding angles are two non-adjacent angles that are on the same side of a transversal with one angle outside the two lines and the other angle on the inside. A couple words in there we probably have to define. So non-adjacent means not next to. It means so angles that are not right next to each other. So if we look down here at our diagram, if we look at this real quick, this is the top part here, we'll see that angles, just look at the top intersection here. So like for example, angle 1, right, has angle 2 and angle 3 are adjacent. They're right next to it, right? Angle 4 is vertical, right? It's not adjacent, it's vertical of it. So just a couple quick reminders of what adjacent and vertical angles are. So we could say that like angle 1 and 3 are what we call a linear pair, and angle 1 and 2 are what we call a linear pair. If you remember this definition, a linear pair has they're supplementary angles, as in they will add up to 180 degrees. That should make sense though, because if a line, right, just flat, that would represent a 180 degree angle. So it makes sense that two angles that are on a line would add up to 180 degrees. So, but we're talking about non-adjacent angles, right? Non-adjacent angles that are on the same side of the transversal. Remember, in the case of this guy down here, remember transversal is just any line that intersects two or more lines on a coordinate plane. So in the case of our example here, a transversal is actually this right here. That's our transversal. Of course, my OneNote is bugging out because why wouldn't it? I'm filming, so why would it not bug out on me? There we go. So in this case, with the corresponding angles, we're looking at two non-adjacent angles on the same side of the transversal. So one on the inside, one on the outside. So in this case, 1 and 6 are example of corresponding angles. We could say that 3 and 8 are examples of corresponding angles. 3 is on the inside, 8 is on the outside. They're both on the same side of the transversal. We could say that 2 and 5 are corresponding angles. 2 is on the outside, 5 is on the inside. They're both on the same side of the transversal. And then finally, we could say that 4 and 7 are also corresponding angles. I kind of also think of these, if you break it down, I kind of like to think of this as if we had just look at the top intersecting point here. So we have our line intersecting the transversal, and then we have another line intersecting the transversal down below. I like to think of it, sometimes it's easier for students to think of this as like, okay, this 1 is on the top left. If we go down here and we pay attention to this intersection point, the 6 is on the top left. So they're kind of in the same position regardless of the location with the intersecting lines. Okay, let's move on to same side interior angles. So same side interior angles are two angles that are on the inside of two lines that are on the same side of the transversal. So notice both corresponding and same side interior angles have to do with the same side of the transversal. So we're not looking at alternate or opposite sides this time. So two angles that are on the inside of two lines that are on the same side of the transversal. So this one's nice because there's really only two we have to know. So in this case, we have angles 3 and angle 6. Those are our example of same side interior. And then we have angles 4 and angles 5. Those are also examples of same side interior angles. So real quick, corresponding angles, they're both being on the same side of the transversal. One's going to be inside, one's going to be outside. Same side interior angles, they're both on the same side of the transversal, and they're both going to be on the inside. Okay, now let's talk about why that matters. Okay, just like with vertical, with alternate exterior and alternate interior angles, there's an established relationship that we can go with if the lines are parallel. So remember, just like with alternate interior and alternate exterior angles, for us to do anything more than just define what the relationship is, we have to know that the lines are parallel. So if we look at this right here, we'll notice that we have these two chevrons, or just arrows. I really don't care if you can know they're chevrons. These indicate that the lines are parallel. So these two lines are parallel to each other, which means they're intersecting the transversal at the same angle. which means all the angles related between these two transaction points are going to have a relationship. So if we're looking at corresponding angles, so I'm going to highlight those real quick. So like 1, 6, 3, 8, 2, and 5, and 4, and 7. If we look at those, right, all those are going to be congruent. Now, if you look at angles 1 and 6, right, they are both very clearly acute angles, right? They're less than 90 degrees, right? It would make sense that they could be equal to each other. Conversely, 3 and 8 are both obtuse angles, which they very clearly visually look like they're greater than 90 degrees, so it makes sense that they could be equal to each other. You can make a similar argument for 2 and 5 and 4 and 7. So the key here, if the lines are parallel, corresponding angles are congruent. Remember, congruent is just a fancy way of saying equals. Now, if we look at this right here, this symbol right here looks really similar to equal, right? That just means congruent, right? So if you have that little tilde above the equal sign, that's an indication that those measures are congruent or equal. Okay, now supplementary angles are, same side interior angles are supplementary angles. Now, if you remember, hopefully you're exposed to this in 7th grade. If not, remember supplementary angle, as we talked about earlier, are just two angles that add up to 180 degrees. Same side interior angles are indeed supplementary angles. So if we look at this, we know that 3 and 6 are same side interior angles. They're both on the inside of the parallel lines, and they're both on the same side of the transversal. And then we could say the same for 4 and 5. Now, unlike our corresponding angles, 3 and 6 are different kinds of angles. So visually looking at 3, this appears to be obtuse. Visually looking at 6, it appears to be acute. So it doesn't make sense that an angle that looks to be greater than 90 degrees would be equal to an angle that looks to be less than 90 degrees. However, it does make sense that these two angles could add up to be 180 degrees. Hence, same side interior angles are not congruent, they are supplementary. So supplementary just means these equal 180 degrees. So today, when we're just kind of identifying what these angles are and recognizing the relationship they have with each other, on Monday or Tuesday, depending on when you have class, we're actually going to go and start setting up equations that involve corresponding and same side interior angles. The key is realizing that corresponding angles, we're going to set up exactly how we set up alternate interior and alternate exterior angles. We're just going to set them equal to each other. Same side interior angles, we're going to add them together and set them equal to 180. So we'll talk about that a little bit more next week, but a little quick preview. All right, for our examples, all we're going to do is go ahead and identify what kind of angle relationship we have between them. So if I'm looking at the first one, so remember all these angles we talked about today are on the same side of the transversal. So I'll mark the transversal in all of these. Remember, the transversal is simply a line that intersects two or more lines. So these are all of my transversals. So here I have 1 and 2. 1 is on the outside of the lines, 2 is on the inside, and then they're both the same side. So we would call these corresponding angles, or just C angles, right? Okay. The next one, we look at this, we have 1 on the inside, 2 on the inside, and they're both on the same side of the transversal. These are same side interior, or SSI. Same side interior, or SSI. Okay. Last one. Okay, the 1 is on the inside of the line, so 2 is on the outside of the lines, and they're on the same side of the transversal. So once again, we have an SSI line angle relationship. So SSI, there you go. So corresponding, oh my gosh, that's wrong. I made a mistake. That is not SSI at all. It happens occasionally. Early in the morning, not enough coffee. So 1's on the inside, 2's on the outside. They're on the same side of the transversal. These are not same side interior. These are corresponding angles. All right. There's my mistake for the day, hopefully. Okay, now we're going to go ahead and name the special angle relationship between the labeled angles, and then we're going to state whether the angles are congruent or supplementary. So right here we have inside, outside, and they're both on the same side of the transversal. And we notice that we have some parallel lines by the chevrons posted there. All right, so since there are on one's on the outside, one's on the inside, we know these are corresponding angles, right? And since they are corresponding angles, we know that they are equal. So I'm just going to put an equal sign there. In fact, I'll do this to say they're congruent. All right, next one. Once again, I see those parallel lines, which means we can do something with these mathematically as opposed to just identifying what they are. They are both on the same side of the transversal, and they are both on the inside. So in this case, we have SSI, our same side interior. And these are supplementary angles, or they add up to 180 degrees. So remember, for setting up an equation to solve for these, you just add them together. All right, next problem. Once again, I see these parallel lines. Okay, so I have the chevrons indicating the lines are parallel. It appears that both of the angles are on the inside, right? And they're on the same side of the transversal. So once again, we have an SSI. And these two angles will add up to 180 degrees. All right, hope this was helpful. If you missed class, there's corresponding homework with this. Your homework just has to do with identifying the angles. Have a good one, and I look forward to seeing you guys later.